Hello, Brady. Oh, you're not in here. Hello, Brady. Can you hear me?
Yep.
Okay. Hello, Ryan. Were you here yesterday? Ryan,
Hello.
were you here yesterday?
No, it was really weird. When I was trying to join, it said waiting. You said another meeting
Oh.
progress, wait, and then it popped up with a invalid meeting ID. And whenever I tried to join after that,
Okay, I don't know. Usually it pops up that I have to admit you each in here. And so I don't know what causes that. And then somebody said I can turn on a ding so I know that people are waiting for me. And I looked for that and I can't find that either. So you were caught into the abyss. You were
yeah,
probably
I was stuck.
drowned by the wheels of the abyss.
Yeah, I was trying to get in, but I couldn't.
Yeah, the door.
It spit me back out.
I'm sorry. Were you able to watch the video?
I haven't. Did you upload the video?
Oh, no, I didn't have a video. I wasn't able to get in either. So I know what happened. It was like I had forgotten to make a meeting. And so I made a meeting and then Zoom froze on me and I couldn't do anything at all. And Kyle got us all into a meeting and he created a meeting for everybody. So Kyle was kind of the savior of the day. And because Kyle was in charge, I couldn't record it.
Cool.
So, but there, if you go to Schoology, I have videos on this and I have my own personal notes also. Okay.
Right.
So you could take a look at it. And we're going to be, hi, Ellie. And we'll probably do a little review for you. Again, these notes are in Schoology and my handwritten notes are in Schoology. We already did number 7, but I might review it. Okay,
Right.
then we'll finish up with 8 and 9, and then I have a AP question from 2019 to give you, just to see what you can do with it. Okay, that's kind of where we're headed. Am I early? Oh no, it's 11 o'clock. You guys know who Lady Gaga is? Have you ever heard of her?
Mm-hmm.
No. You're laughing at me. Did she
No.
really wear a meat suit one time? Is that true?
It was a meat dress, and
A
yes.
meat dress? And so I take it she's not a vegetarian.
Probably not.
Or, yeah. We were talking about Lady Gaga, Ryan.
Nice.
Yeah.
What about her?
Well, my wife schedules my life as it should be. Okay. And so I see there's a show called Lady Gaga and Friends coming up. And so I had to Google who Lady Gaga was. And she wore a meat dress,
Yeah.
which sounds really disgusting to me. I take it wasn't cooked. It was like raw.
Yeah, it was raw meat.
So, you know, like when you put raw meat out, flies and all that kind of stuff kind of gather around, it just does not sound good. How come
Imagine
it's
the
only-
sound.
Huh?
Imagine the sound for walking around.
It's so cool to hear your voice, John.
Aaron and Kyle can't get in, so I'm trying to help them.
Well, I don't know. I did everything right this time. And I've been admitting Kyle.
Oh, there she is. Amy.
Aaron. And there's Kyle. There's Hannah. 1, 2, 3, 4, 5, 6, 7. Just waiting for a few more people. Went for a walk at Quarry Park yesterday. Do you guys know where Quarry Park? Have I told you about this before? A little muddy, but man. And then we go to by Whitney, you know, where what we call the Boy Scout Bridge, where that is. You guys ever been there? You can get there from the Sartell end by Walmart. There's an entrance over there. It's kind of a neat park. It's not very long, but it's nice. Rosie likes it. I think there's a lot of stuff to smell. All right, we got 1, 2, 3, 4, 5, 6, 7, 8.
Hi.
Hi, how are you?
Sorry, I was at the wrong link.
Yeah, I know. I'm trying to. There's so many little tiny. I'm not very good with detailed stuff. I'm okay with I'm a big picture person, and I
Yeah.
know I'm willing to pay people big money to do small details. And when I have to sit there and schedule, that's how I screwed up yesterday. I went, oh, I forgot to schedule my meeting, so I tried to schedule them in advance. Do the reoccurring one. I don't know if that's a good decision or not, so we'll find out. So who's missing here? Hannah.
I don't know, but I'll be right back. I need to go grab the notes I just printed.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hannah would be 10. Yeah. So we'll wait till John gets back and then we'll start. Oh, I got a new thing. Rather than write on a tablet, Karsh said, go get your document camera. So I got Bugsy. And so I'll actually be able to write on a piece of paper and you'll be able to see what I'm writing on. So I'm actually kind of excited about that. Hi, Hannah. How are you? Hi, Hannah. How are you? Okay, so what I'm going to do is, I don't know, John, are you back yet? Hello, John. We only have 3 things to do from yesterday's notes. So I'm going to review number 7. I'm going to have somebody talk us through number 7. And then we'll do number 8 and 9. And then I have a problem I want you to do that is a AP question from last year. Okay? Because I looked again a little bit closer at what AP said they'll test you on, and they said it is open book, open notebook. And I remember taking a class when I worked on my master's degree, and there were 35 of us in this class. 3 of us were graduate students, and every test was timed, was open book, open notebook. And 32 students cheered, 3 did not cheer. Because when it's open, it means anything's available. And so it makes me rather anxious. So I need to do a good job to get you guys prepared. So I'm very concerned about that. Okay. You should have noticed I started entering scores yesterday. Okay. So you may want to take a look at where you're at and what scores I put in case I made any mistakes, which the probability is probably 30%. There's probably anywhere between a 30-40% probability of me making a mistake doing anything. So that's just kind of the way my life goes. So I'm going to give you this. John, are you back?
Yes, I am.
Okay. All right. So I'm going to share this. And can you guys see this okay?
Mhm.
All righty. So here's number 7. And Brady, you remember number 7?
No, I do not.
Okay. Do you know how we want to start this?
It's just a white screen for me. I don't see anything.
Is that true for everybody?
Yeah.
White screen? Maybe I'm sharing the wrong thing. Let me get out of here. Try this again.
Ow.
Oh, I did. I clicked on the wrong thing. Is that better?
Yeah.
Yeah. Do you see words?
Yeah. Oh, it's live. Fancy.
Sorry about that. And the sun came out, and I got the blinds open. So we'll see how this goes. This is kind of like being in the classroom, sitting next to the window. I'm going to ask you this, Brady, and we'll walk you through this. What's a sub n?
A sub n, is
Yeah.
it -1 to the n plus 1
Perfect. Times what?
times 1 over n factorial?
And factorial. Do you remember what factorial means?
Sort of. It's
Okay, let
all
me give you my favorite factorial. 3 factorial.
1 times 2 times 3.
1 times 2 times 3, right?
Yeah.
Okay. And so 4 factorial, I'd multiply that by 4. Correct?
Yeah.
Okay.
Yep.
So what's b sub n here?
Is it just 1 over n factorial? Or is it the
1 over n factorial. Perfect.
Okay.
And if I take a look at this, if I took the limit of this, it'd head to 0, correct? Because eventually, try doing 10 factorial on your calculator. Usually that's too large of a computation for it. It's really amazing how factorial just blows. Factorial grows faster than exponential. And the other thing that's cool about it, it took a long time to figure out what function factorial belonged to and how to take the derivative of that function, which is all possible now due to some complicated math. All right, so now we know that S, what does S stand for?
uh,
It stands for the true sum of this series. So if you would go to infinity and shake its hand and say, hey, what is the true sum of this series? It would be able to tell you. But we'll never be able to do that. And so what we do is estimate it. And S sub n isn't the true sum, it's what we call a partial sum. It's adding up the terms, whatever this n is. So if I had S of 3, that would be 1 plus 1 over 2 factorial, which is 1 times 2, which is 2, plus 1 over 3 factorial. Oops, I screwed up here. It's going to alternate. Negative here, plus 1/3, plus 1/6, sorry. And those would be the first 4 terms. The fourth term, Ryan Burkhart, would be what? Let me put a 4 here.
Wait, what? Sorry, 1 over 24? Or?
1 over 24, perfect, because you'd multiply 6 by 4, correct?
Yeah.
And the alternating series theorem says we can figure out a boundary in which the true sum lies. Because if we take a look at this and say, all right, S is equal the sum of the first 3 terms plus all the terms after those first 3. And this can be rewritten as S minus S3, absolute value, is equal to the remaining terms. There's not 3 of them. It's just the remaining terms after the first 3. That's what that means. That is going to be less than the next term in the series, which in this case is a to the 4th. So in other words, our true sum, if I have minus, what did we say? Ooh, what is 1 minus a half Hannah Trelfa?
1/2.
1/2. What's 1/2 plus 1/6?
2/3.
2/3. Minus 2/3 is going to have to be less than or equal to this 4th term. And so S minus 2/3 is somewhere between, Ryan Zaski, 1/24 and a negative 1/24, because this was absolute value. And I'm going to write this up here, move this up here because I'm making such a mess. And I got something that just popped on my screen that I find really irritating right now. There we go. So that means that a negative 1/24 plus 2/3 is less than my sum, which is less than 1/24 plus 2/3, which is basically saying I'm at 2/3. My true sum is plus or minus 1/24 on either side of that. And so if I figure this out, I think I get 15/24. Is that right, Gavin?
Yeah, that's right.
Okay. And over here, if I add this, I get 17/24. Does that seem correct?
Yeah.
So my true sum is somewhere between 15/24 and 17/24. So I've got a pretty good estimate of where it's at. Ryan Zasky, does that make sense?
A little, maybe. I don't know.
Okay. Okay, this is the part that you need to understand to figure out what that's between. And if you look on the previous ones, so what we're saying here, if I take the true sum minus my approximate sum to whatever number of terms I choose, that's going to be equal. Now I subtract those, it's going to be equal to the sum of my remaining terms. This is an n right here. Someone with a lot of math knowledge said this remaining will always be less than or equal to the next term in the series. So if you stopped at 5, this would be a sub 6. So if you added up the first 5 terms, the sum of the remaining terms has to be less than the 6th term. All right, we kind of headed towards this. Example 8. It says, all right, determine the number of terms I need to approximate the sum. Now, again, this only works on an alternating series. So it goes from plus, minus, or minus, plus, something like that. It says, determine the number of terms required to approximate the sum of this series with an error less than 0.001. And Kyle, you gave us an indication you had an idea of how to do this.
Yeah, so you just do all the terms until you get to a number that's less than 1/1000.
Okay, so I know that the sum n plus 1 has to be less than or equal to this, correct? Right? And we're saying it, we want it less than this, correct? Is that what you're saying?
Yeah.
Okay. And so what I could do in here, and since this is positive, whether I'm negative or positive, I make, since it's the absolute value, this has to be positive, correct? Kyle?
Yeah, I think so.
Yeah. And so this is going to be 1 over n plus 1 squared, because the absolute value of a sub n is going to be 1 over n squared. The next term is going to be n plus 1 squared. Is that correct, Kyle?
Mm-hmm.
Okay, and that's got to be less than or equal to 0.001. Am I right?
Yeah.
Okay, so how would you solve that?
I was just thinking about like just doing each one until you get to a value, but you just multiply both sides by n plus 1 squared, right?
Okay, so over here I have n plus 1 squared. Am I going to divide by something over here?
Yeah, and you can even move the 1/1000th over, so it'll be 1000 is,
This is 1,000.
yeah, 1000 is less than n plus 1 squared, so it'd be, is it 10 square root of 10 is less than,
Well, it's gonna be the square root of 1,000, right?
yeah, which is 10 square root of 10. Oh, you don't have to simplify though.
Yeah, we're
Okay,
gonna
so square root of 1,000 is
minus,
less than, oh
minus
yeah, minus
1,
1 is less than it.
less than that. Okay, so I figured that out already. I think I had it written down somewhere. Oh. So I get this. Oh, I did it wrong. That's why. I'm going, that's not the answer I got.
So you get it like about 30.
Yeah, I got 30 point something, right?
Mm-hmm.
I got 30.623. Well, so that I can't have those number of terms, can I? Right? So what do you think AP is going to look for? How many terms? Kyle.
I don't know. Wait, what do you mean by terms?
Well, n is the number of terms, correct? It says
Yeah.
determine the number of terms required to approximate the sum of the series. And this is when they're equal, correct? And n's got to be greater than that, correct?
Yeah.
So what's the, obviously, if you go to a bazillion terms, you're going to be okay, but
Yeah, so 31.
31, right? And you got to go, the first time you're going to meet it is at 31 terms, right?
Yeah.
Okay, so let's take a look at the next one. Ellie, you ready?
Maybe.
Okay. The absolute value of a sub n is 1 over 2n factorial. So my question is, what's the absolute value of n plus 1 in this case?
This whole factorial thing is throwing me off.
Yeah.
I'm not gonna lie to you.
Yeah, and you know what? You're not, it's not a new thing. And I used to assume it was easy to see. And then last year and the year before, well, I had 2 years of people screaming at me. You're nice. You're not screaming at me. So, but you're honest, and I really appreciate that. So I'm going to say, here's n, right? And if n is 1, I'd have 1 over 2 factorial, which would be 1/2, because that'd be 1 times 2, correct? And so what I do, I struggled also. And so what I did is I look for a pattern, and then so would you agree that I'd have 1 over 4 factorial here?
Yes.
Okay, which would be 1 times 2 times 3 times 4. I think I get 1/24. Okay, so if this is my first term, this is my n plus 1 term, and I get this. Okay, and so if I have 3, I'd have 1 over 6 factorial. Would you agree with that?
Yes.
Which I think is, if I multiply this by 5, I get 120. And if I multiply 120 by 6, I believe I get 1 over 720. It gets big really fast. Okay? And so what I can do here is I'm really replacing n with n plus 1. So this n becomes n plus 1. And so now I have 1 over 2n plus 2, that factorial. So I check. When n is, yeah, so that would be my next term. So if when I was at 1, my next term would be 4. When I was at 2, my next term would be 6. Because if I put 2 in here, I'll get 6, correct?
Yeah.
Okay. So let's take a look at this. I'm looking to see where I have an error less than 0.001. So I could actually use this chart. Here I have 0.5, correct? That's definitely not less than 0.001, is it?
Right.
Okay. So do you have a calculator in front of you or no?
I do.
You do?
0.401 or something like that.
Okay, but 0.4 is not nearly enough. What about now?
Yes. That would be 0.0013 or 14, I mean.
1.4. Really? 0.0014? That's
Yeah.
bigger than 0.001, isn't it?
Yep.
So I got to go one more, don't I?
Mhm.
Correct?
Yeah.
So how many terms am I going to need? Oh, excuse me, Ellie. We were supposed to start at 0. Do you see that here?
Hmm.
Somebody needs to read. So if I have 0 here, do you know what 0 factorial is?
0.
That's 1.
Uh,
Yeah, it's a big controversy in math. People got into fights over it. So on 1 here, I would have 1/2. And over here, I would have 2. And I would have, when I had 2, what did I have? 1/24.
Yep.
And when I had 3, I had 1/720, I think.
Yep.
So now 0, 1, 2, 3. And did this one work or no?
nope, that one's too big.
So this one, it worked, correct? We got less than 0.001, correct?
We have not, or at least I have not done it all the way through yet.
Well, but you definitely get something less than
Right.
that.
It would make sense for it to be because it gets it gets a ton smaller. So that would make sense.
Yeah.
Right. So how many terms do I need?
4.
Well, here's the first term, right? We started at 0.
Oh, so then it's 5.
Second term, third term, fourth term,
So then it's 5.
5. Okay, so we need 5 terms.
So Kruger, can you do a negative number 2 factorial?
Can you? Actually, there was a student in Mr. Karsh's room. Oh, Ellie, I got to back up. This is where when n plus 1 is less than 0.001, and now I'll
Yeah.
get back to Kyle's question.
So it'd be n equals 3.
Right, because
Yeah.
we ended up having 3 plus 1 less than or equals 0. So here's, once we get here, we look at this term, and when we look at this term and realize, hey, it's less than this, we can stop at adding up these 4 terms. So the answer is 4 terms.
I
Sorry.
was thinking about that.
Yeah. So anyway, there was a student a number of years ago, and I'll have to ask Mr. Karsh about that, that actually created a system in which he had negative factorial and how it affected, because you use the factorial with binomial expansion. Do you know what I mean by binomial expansion? It's like taking x plus y to the 15th power. You know, you guys,
Oh, yeah.
we have
Yeah.
combinatorics, and we use
Yeah.
factorial in that, and that's why, because of the binomial expansion, that's why 0 has been defined, 0 factorial as being 1. Okay, there's no mathematics behind it. Somebody who had a lot of power just said, hey, it works if we make 0 factorial 1, so that's what it'll be. We have no idea what it is, but we're just saying that's the way it's going.
Oh, okay.
Okay. And so because of binomial expansion, that's why you have to do that. The binomial.
So if it's, but can you take the factorial of a negative number?
Right. So this kid looked at factorial of a negative number and created a system and then used it for binomial expansion. And I wish Mr. Karsh, I think, still has the kid's notes, and he shared it with some professors at St. Cloud State. And that's as much as I remember. I can't remember the student's name. I can't remember the result. I'll talk after class, I'll send Mr. Karsh a message and see if he can send it to me.
Okay.
And send it to you. So yeah, somebody did, that's just like with anything in math. How is a lot of mathematics created? Somebody says, either I don't disagree or what if? What if we had more than 3 dimensions? What would the 4th, 5th, 6th dimension look like? And so if you take a look at Einstein's attempt for a unifying theorem, do you know what I mean by a unifying theorem, Kyle? So you have, how does Einstein's theory of relativity apply to the molecules and atoms and nuclei? Because you have orbiting concepts there, correct?
I think you lost me.
So he was saying, all right, how do you take a look at molecules and apply the theories of cosmology with planets and black holes? How do they work in the terms of molecules? And so he said there should be a unifying theorem that takes care of both of that.
Oh, okay.
So there's a number of mathematicians that do that. Well, if you look at multi-dimensional space, it starts to work. And so that's how people come up with these ideas. They say, okay, what if we had something like this? And all of a sudden you start finding applications based on that.
All right.
Okay, back to me getting back on track. Okay, so here's a problem I want you to do. Okay, and it is 11:31 right now. I'd write these down. I'd say, number 5, consider the family of functions f of x equals 1 over x squared minus 2x plus k, where k is a constant. A is find the value of k for k greater than 0. In other words, k's got to be positive, such that the slope of the tangent line to the graph of f at x equals 0 equals 6. That's your first step. Secondly, B, for k equals -8, find the value of the integral from 0 to 1 of f of x dx. C, for k equals 1, find the value from 0 to 2 of f of x dx, or show that it diverges. So this was from last year. This was the fifth question from AP Calculus BC. I think this is something that you could get. I think this was non-calculator, but a lot of times they mix non-calculator with calculator. You will be able to use the calculator on the exam. I don't think you need it on this one. So what I would like to do is you guys work on this and send me your solutions. Take a picture of it, send me solutions, and I'll talk about it tomorrow. How does that sound?
Can you like lower your shades or something? Because it's kind of cut off because it's too bright.
Okay. Is that much better?
Yeah.
And I will, so see if you can figure this out by yourself, and we'll talk about it tomorrow. Anybody have any questions about that? And then I'll have you score it in class. It gives you an idea of where you're at. And then Thursday, I think I'll start Taylor polynomials. All righty. Any questions at all? Well, you guys have a pleasant day and we'll see you tomorrow. Okay?
Bye. See you tomorrow.
Yeah, so send
Okay.
me your answers on these. You can just put them on a piece of paper. I got to talk to the AB people. They've been sending me little strips of paper, taking pictures of little strips. That doesn't help, especially when they're upside down or vertical and I got to rotate them or something. Put your work on one piece of paper, take a picture, send it to me. Okay? All righty. Sometime by tomorrow. Take care. And we'll see
Bye.
everyone tomorrow.
Bye.